Hello all, welcome to Paritranaya. In this class, we will be discussing about a very important topic, that is globe and latitudes and longitudes. So why this topic is important? Because in our day-to-day life, we use many applications like Google Map, Uber, Ola, or many other applications. And all these applications internally, they work through the concept of latitude and longitudes. So how are these beneficial latitudes and longitudes? So latitude and longitude together, they help us to identify a place on Earth very accurately. Okay, very accurately. So for this, first we need to understand the shape of the Earth. Okay, how it is. So based upon that, then next we can understand the concept of latitude and longitude. So in order to understand about our Earth, so what kind of a shape does Earth has? Our planet? It's not a sphere. So most of us, we have an understanding that Earth is like a sphere, but it is not sphere. So if you look here, the perfect model in order to learn Earth is globe. So here we have shown a globe. So if we study globe, then, or if we look at globe, exactly or more or less Earth is like this. So with the help of this, understanding of latitudes and longitudes will become easier. So if you look at this globe, it is slightly flattened at north and the south poles, and bulge in the middle. So these points, this is called as North Pole, and this point it is called as South Pole. So here at North Pole and South Pole, slightly it is flattened, whereas at the middle part it is bulged. Okay, bulged. So this is a miniature form of Earth. Here countries, continents and oceans are shown to their correct size. Continents and oceans are shown to their shown in their correct size. That is relative size. What does it indicate? So physically, so what if we want to represent a distance, let us assume it is 10 kilometers. But on a map, if I want to represent it, then it will be like a small dot. I have to scale it, the physical 10 kilometers to this dot. Similar fashion, so physically if the country is so big, then while representing on map, I'll show it small. So in this fashion, each and every continent, oceans and countries are according to their proportion. Okay, according to their proportion. So in this fashion, it becomes a perfect miniature model to study about the Earth. So latitude and longitude, they help us to describe the location of a point on Earth. So how do they help? We shall see later on. So now look at this globe. First we shall understand about this globe. So a needle is fixed. See, there are a few concepts that we need to understand here. So first is, we need to understand about what is axis. We need to understand what is North Pole, what is South Pole. Okay, so all these things we need to understand. So a needle is fixed through the globe in a tilted manner, which is called axis. So here an imaginary needle exists. So this is called as axis. Next, 2 points on the globe through which a needle passes through are 2 poles, North Pole and South Pole. So this point here, it is called as North Pole, and this point here, it is called as South Pole. North Pole and South Pole. Next, globe can be moved around this needle from west to east. Very important. As the Earth moves. Okay. So how does the Earth moves? From west to east. So what is west to east? Now if imagine me as an Earth. So if I move from this direction to this direction, so this is called as west to east. If I move in this direction, then it will be called as east to west. For you it is east to west. So here this globe, it rotates in this fashion. Okay, from west to east. So similarly, in reality, Earth also rotates from west to east. Next, the real Earth has no such needle. So as I already told, so here we took an imaginary needle, which we call it as axis. But in reality, Earth does not have any such needle. Then why we have drawn a needle? So just in order to create the imagination easily, so Earth rotates around its axis. So we have an imaginary line here. So around this axis, Earth rotates. Okay, which is an imaginary line. Okay, imaginary line. Next, similarly, like axis, we have one more imaginary line, which we call it as equator. So where does equator lie? Equator lies exactly here in the center. So what this equator lies? What does this equator do? It divides the Earth into 2 equal parts. So this is one part and this is other part. So the imaginary line which crosses exactly through the center, it divides the earth into two equal parts. So this part is called as northern hemisphere. So this part is called as northern hemisphere and this part is called as southern hemisphere. And both the halves are equal. Means northern hemisphere and southern hemisphere, more or less they are equal. They are equal. Next, latitudes. We come across next concept, that is latitudes. Okay, latitudes. So here, all parallel circles from equator up to the poles are called parallels of latitudes. So where is equator here? So here we have equator. Here we have equator. So where are poles? So north pole is visible here. So here down somewhere here we have south pole, which is not visible on this what picture? Okay, on this picture, but it exists. So all circles parallel. Now this is the equator. This is a circle. So this will be a circle because Earth is what in round shape. So there will be a circle. So similarly here we have one more circle. Okay, circle 1, 2, 3, 4. And so on. Similarly, here also we have a circle. We have a circle. So these circles we call them as parallels of latitude. So this is one parallel of latitude. This is another parallel of latitude. Parallels of latitude. Okay, parallels of latitude. Next, they are measured in degrees. Okay, these parallels of latitude we require measurement, right? So they are measured in degrees. Okay, degrees. So equator represents 0 degree. So here we have equator. Equator is 0 degree. So as we move towards the poles, the degree increases. So here we will be having the next circle which we will be having here is 1 degree, next 2 degree, 3 degree, 4 degree and so on. So we have shown here 20 degree, 21, 22, 23 and so on, 40 degree. Here we have 60 degree, 80 degree, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90. So this north pole, this will be 90 degree. This will be 90 degree. Similarly, when we move towards the southern direction, so here south will also be having 90 degree. 10, 20, 30, 40, 50, 60, 70, 80, 90. But we want to distinguish it. We want to distinguish north pole from south pole. And we also distinguish this, this line from this line. Okay. So how do we distinguish? We distinguish it by using a what? Symbols N. So here I will use N. This indicates towards north. So this is 20 degree north and this is 20 degree south. Similarly, here we have 40 degree north, and if we move towards the south, we will be having 40 degree south. So here 90 degree north is north pole, 90 degree south will be south pole. Okay, south pole. Next, why we have used 90 degree? Okay, so the reason for that, here we have that reason. So distance from the equator to the poles. Distance from equator to the poles. So this is equator. So from here equator, what will be the distance to the pole? So let us assume it is 1 kilometer. Just in order to make our discussions easier, let us assume 1 kilometer. So what will be the distance from this equator to the south pole? Here also it will be 1 kilometer. Okay. So from that side, from north pole to the other side where it touches the equator, that will also be 1 kilometer. And from there to here, again 1 kilometer. So totally the circumference of the earth will be 4 kilometer. Okay, 4. If the circumference of the earth is 4 kilometer, then 1/4 means 1 kilometer. Similarly, if we take a circumference full round, then it will be 360 degrees. Okay, 360 degrees. But 1/4 of 360 degrees, 90 degree. 1/4 of 360 degrees, 90 degree. That is why north pole is located as 90 degree north, south pole is located at 90 degree south. 90 degree south. So here what we understood? Parallels of latitudes. So those who are present towards the north of equator, we call it as what? They are present in what? Northern hemisphere. And those who are present here, we call that they are present in southern hemisphere. Next, 90 degree north latitude marks the north pole. As we discussed, 90 degree north latitude marks the north pole, and 90 degree south indicates south pole. Okay, south pole. Next, north latitudes. Which are called as north latitudes? All parallels north of equator are called as north latitudes. So in this example, all these latitudes, 20 degree north, 40 degree north, 60 degree north and 80 degree north, all of them they are called as north latitudes. And all those who lie to the south of equator, they are called as south latitudes. They are called as south latitudes. Next, value of each latitude is either followed by word north or south, and they are indicated by the letter N or S. Okay, so here we have indicated north to indicate that this latitude is present towards the, it's a north latitude, and here we have indicated yes, indicating that it is a south latitude. Okay, south latitude. Next, so here we have shown some random latitudes, 20 degree, 40 degree, 60 degree, 80 degree and all. But among these various parallels of latitudes, there are few parallels of latitudes which are very important. Okay, very important. Why they are important? Now beyond the scope of discussion, but they are important. So next we shall see about those important parallels of latitude. Those important parallels of latitude. Already we know about equator. So equator lies here. So this is equator. Next, North Pole also already we have seen. So here we have North Pole. Here we have North Pole. South Pole also already we have seen. So here exists South Pole. So next an important latitude is Tropic of Cancer. Tropic of Cancer. So what is its degree? It is 23.5 degree. Okay, 23.5 degree. So it indicates, and here we have N. It indicates it's a north latitude. So here we have Tropic of Cancer, 23.5 degree north. So here we have indicated 23.5 degree north. Tropic of Cancer. Similarly, Tropic of Capricorn, 23.5 degree, but it is south. It means it is in the southern hemisphere. So here we have Tropic of what? Sorry, it is Tropic of Capricorn, 23.5 degree south. Next, apart from that, we have Arctic Circle, 66.5 degree north. So this is Arctic Circle, 66.5 degree north. We have Antarctic Circle, that is 66.5 degree south. So in this class, or in here, what we discussed? We discussed about equator, Tropic of Cancer, Tropic of Capricorn, Arctic Circle and Antarctic Circle. So all these are important latitudes. Okay, important parallels of latitude. Next, see here. Here next we will be studying about heat zones. Okay, there are important heat zones. So the zone which is present between Tropic of Cancer and Tropic of Capricorn. Tropic of Capricorn. It is called as torrid zone. So where does that zone exist? So this area. This area we call it as what? Torrid zone. So the midday sun is exactly overhead at least once a year on all latitudes here. So this area therefore receives the maximum heat. So in this area, in 1 year, at least once, so the sun will exactly shine overhead. Okay, exactly shine overhead at least for 1 day. Okay, 1 day. So that is why compared to the other areas which are present over here and which are present over here, so this area it receives maximum heat. Okay, receives maximum heat. So in exam questions can be asked like this. So which of the following areas or zones receive maximum heat? So they may give you like options like torrid zone, temperate zone and all. So here we have to remember it is torrid zone which receives the maximum heat. Okay, receives the maximum heat. Next we have temperate zones. So here when it comes to temperate zones, in the northern hemisphere also we have temperate zone, and in the southern hemisphere also we have temperate zone. In both the hemispheres we have temperate zone. So here in the northern hemisphere, the region which lies, so first we need to understand what is northern hemisphere. From equator towards the pole, this is northern hemisphere. From equator towards the south or south pole, this is southern hemisphere. So between Tropic of Cancer and Arctic Circle in the northern hemisphere, so here this area it is called as temperate zone. This area it is called as temperate zone, north temperate zone. Similarly, the area between Tropic of Capricorn and Antarctic Circle. So Tropic of Capricorn and Antarctic Circle. So this is also temperate zone, that is south temperate zone. Okay, south temperate zone. Next, here in the temperate zones, the midday sun never shines overhead on any of the latitudes beyond the Tropic of Cancer in the northern hemisphere and Tropic of Capricorn in the southern hemisphere. So what happens here is the sun's rays will never fall directly, means overhead, on these latitudes or in this area. So sun will on none of the days will directly appear overhead. Okay, overhead. So that is why relatively they receive less heat. So this region, these two regions, they relatively receive less heat compared to torrid zone. Okay, compared to torrid zone. Therefore, these areas have moderate temperatures. Okay, moderate temperatures compared to what? Torrid zone. Next, frigid zones. So frigid zones are very cold. Okay, very cold. So where are they located? They are located in both northern hemisphere as well as southern hemisphere. In the northern hemisphere, between Arctic Circle and North Pole. So this is the area in the northern hemisphere which is a frigid zone. Next, similarly in the southern hemisphere, between Antarctic Circle and South Pole, so this is what? Frigid zone, very cold, between Antarctic Circle and South Pole, very cold. Why? Because the sun does not rise much above the horizon. So what does it indicate? Horizon. So now you are watching this video, so my eye and your eyes, both of them, they are horizon, they are almost horizontal. Okay, horizontal. Now generally if you look at the sun on midday, it will come on my top, it will come to my top, almost over my head. Okay, it will be too much hot. But if the sun hardly rises below the horizon, so for you hardly, it may not arise more than this. So in this case what happens? You will receive very less heat. You will receive very less heat. Only when the sun rises up and up, we will start receiving more and more heat. But if the sun hardly rises to this extent, then you will receive very less heat. That is why these frigid zones, they are what? Very cold, because they receive very less heat from the sun, because the sun does not rise much above the horizon. Therefore its rays are always slanting and provides less heat. Okay, less heat. So among the three zones, torrid zone receives the highest heat. Next, moderate heat is received by these two regions, and very less heat, they are very much cold. So which are those zones? Frigid zones, which are present over here, okay. Next, so we saw about latitude. Next we will see about longitude. Okay, longitude. So the lines which existed in this fashion, okay, in this fashion, we call them as what? Latitudes. Okay, latitudes. Next, here we are seeing line which are vertical. Okay, which are vertical. So they are called as longitudes. They are called as longitudes. So lines of references running from North Pole to South Pole. North Pole to South Pole. So there are various lines running over here. So this is one longitude, this is another longitude, and so on. Okay, and so on. So what we'll call them as? We'll call them as meridians of longitude. So this is one meridian of longitude, meridian of longitude, meridian of longitude, and so on. In case of latitudes, we use the term what? Parallels of latitude. In case of meridians, we are using the term, sorry, in case of longitude, we are using the term meridians of longitude. Parallels of latitude, meridians of longitude, meridians of longitude. So they help in locating a point on Earth more precisely. How exactly we'll get to know. So first we shall understand distances between them are measured in degrees of longitude. Degrees of longitude. So now generally when it comes to physical distance between two places, we generally use kilometer or meter and all. But here distance between two longitudes is measured in terms of degrees. Now initially you may get confused, but don't get confused. So just for time being, assume that between two longitudes, distance is always measured by degrees. Okay, 1 degree, 2 degree, 3 degree, 4 degree, and so on. Okay, so on. Next, each and every degree, 1 degree has many minutes. So 1 degree has 60 minutes. Okay, so this minute is represented in this fashion. Next, each minute has 60 seconds. 60 seconds. Okay, 60 seconds. It is something similar to kilometer. So 1 kilometer consists of 1000 meters. So 1 meter consists of so and so millimeter. Okay. In the similar fashion, distance between two meridians is measured in terms of degree. And each degree internally, if you want to convert it into in the form of what? Minutes, then each degree will be what? 60 minutes and so on. Okay. So distance is measured with the help of degree. Each degree consists of few minutes. Each minute has few seconds. Okay. Few seconds. Next. Another important point here, just note it. They are semicircles. They are not complete circles. So if you saw parallels of latitude, they were complete circles. Okay, they are complete circles. They are complete circles. But here, in case of longitude, they are not complete circles. They are semicircles. Why? Because they start here and they end here. So compared to latitudes, longitudes are semicircles. Okay, semicircles. And one more important point to note here is distance between longitudes decrease steadily polewards until it becomes zero at the poles. So what does it mean? So if we consider two longitudes. So this is one longitude, another longitude. Okay, one meridian of longitude, another meridian of longitude. So if you see here, distance is more. As we move towards the poles, what happens? The distance between these two lines is being decreased. It goes on decreasing. So to what extent? At the North Pole, the distance becomes 0. The distance becomes 0. Similarly, at the South Pole, the distance becomes 0. The distance between two meridians of longitude will become 0. So even this property is very important for us to understand. Okay, it is very important for us to understand. So here, unlike parallels of latitude, all meridians are of equal length. Hence, difficult to number the meridians. Okay, very important. Now, let us go back to the previous longitudes. So see here. Now this equator. So whether equator and the another latitude, both of them will be of equal length? No. Okay. So equator's length will be more and its length will be less, and so on. As we go towards the pole, so the length, it will go on decreasing, and finally it will go on decreasing. But when it comes to longitudes, so the length remains the same. Okay, length remains the same. So that is why it will be difficult to distinguish. It will be difficult to distinguish. For example, when it comes to latitudes, we'll take the central line. We'll take the central line and use it as a reference, and we call it as 0 degree, and we'll call it as equator. Okay, and we'll call it as equator. Why we'll take it as a reference? Because it is the longest line. This will be the longest line which exactly divides Earth into two equal parts. So this line we'll use it as a reference. Okay, a reference. But when it comes to longitude, all of them are of equal length. All meridians are of equal length. Hence, if you want a reference line, it will be difficult to start. Otherwise, we have to assume one line as a reference line. So one line as a reference line we should assume, and we should call it as 0 degree, and then we should start counting. Okay, and then we should start counting. Hence, in order to overcome this difficulty, all the countries, they came together and they agreed that we should fix one line as a standard line. And let us consider it as 0 degree. Okay, let us consider it as 0 degree. So one line was fixed. Which is that line? The line or the longitude which passes through Greenwich. So Greenwich is a city which is present in UK. So let us assume this is the one line which goes through Greenwich city in UK. So this line, all of them, they came to an agreement that this should be accepted as a standard line. Now the next question comes, why did we go for Greenwich? So that is beyond our scope of discussion. Okay, so why they fixed, we will not worry about it, but they took Greenwich as a standard line. So this standard line was assumed as 0 degree. Okay, 0 degree, and we'll call it as prime meridian. So this prime meridian is 0 degree longitude. So from it, if we count eastward, then 180 degree eastward and 180 degree westward. So if we take this as a standard, then we'll start moving in the eastward direction, and if we start moving here, it will be westward direction. So next, from 0 degree, next will be 1 degree longitude, 2 degree, 3 degree, 4 degree, 5 degree, 6 degree, 7 degrees, 8 degree, and so on. So what will be the maximum degree that we will have here? 180 degree. Okay, 180 degree. So if we move in this direction, then it will be 180 degree. If we move in this direction, then the maximum degree that we can have here is 180 degree. Okay, 180 degree. So in this way, when towards the east we move, so here we call it as what? This is towards the east and this is towards the west. Okay, this is towards the west. Here the prime meridian, what it does is it divides. Okay, the prime meridian and the 180 degree meridian divide the earth into two equal halves. So what does it mean? So here let us consider this as prime meridian. This is prime meridian. So this is 0 degree. If I go on counting 1, 2, 3, 4, 5, 180 degree, where 180 degree will come? Exactly on the opposite side of the earth. Okay, on the opposite side of the earth, we'll be having 180 degree. So this 0 degree and 180 degree meridian, they will divide the earth into two equal parts. Okay, into two equal parts. So towards the right, it will be called as eastern hemisphere, and towards the west, it will be called as western hemisphere. So eastern hemisphere towards the right of what standard meridian, and western hemisphere towards the left of what prime meridian. So similar to what north and south latitudes, we'll be using letters E for east towards east and W for west. So that is why if you look at this example, see what we'll find. So this is 0 degree, this is 30 degree west. This is 30 degree west because it exists towards the west. This is 60 degree west, and here 30 degree east, 60 degree east, and so on, okay, and so on. So it's interesting to note that 180 degree east and 180 degree west are in the same line. From this point, from this standard meridian, when you start moving towards the east, so 180 degree means exactly where you will come, the other side of the earth, exactly on this line. Similarly, if you start moving in this direction, the other side of the earth exactly on that point. So it means 180 degree east and 180 degree west, both of them, they converge. They are on the same line. Same line. So here. So this is equator. This is prime meridian. So let us try to recap it. So from equator, these are parallels of latitude. So if you look at the parallels of latitude, as we move towards the poles, so those parallels will become smaller in length. But when you look at the longitudes, they are of equal size. Now, if at all we want to locate a particular point, if I want to locate this particular point, so what is required for me? I require latitude and longitude points. Okay, so this will be the longitude and this will be the latitude. With the help of this latitude and longitude, we'll be able to identify a point properly on Earth. Okay, on Earth. Now, next, is there any relationship between latitude and time? Is there any relationship between latitude and time? No, there is no relationship between latitude and time. There is no relationship between latitude and time. But is there any relationship between longitude and time? Yes, relationship exists between longitude and time. Okay, longitude and time. So best means of measuring time is by the movement of the earth, the moon, and the planets. Okay, sun regularly rises and sets every day, and naturally it is best timekeeper throughout the world. So generally, if I want to tune my watch to a perfect time, okay, perfect time is local time. So when the sun is exactly overhead, I'll set my watch to noon. When it is exactly overhead. Okay, exactly overhead. Now my question is whether sun will be exactly overhead at all the places at the same time? No. Okay, no. It varies based on longitude. So that's why now whatever the time we are witnessing here, it will be called as local time. So the local time which is present in our place may not be the same at the other place. It will be different. Okay, it will be different. So here are some important points we shall note. So how to find local time? So local time can be reckoned by the shadow cast by the sun. So shadow cast by the sun, it is shortest at noon. Okay, at shortest at noon at 12 o'clock, and longest at sunshine, sunset and sunrise. Okay, sunrise and sunset. So again, these kind of questions can be asked in prelims. So our shadow will be what? Longest at what time? Whether during noon or during sunrise or during sunset. Such kind of questions can also be asked. So based on this, we can fix the local time. For example, at any place, a watch can be adjusted to read 12 o'clock when the sun is at the highest point on the sky. That is when it is midday. The time shown by such a watch will give the local time for that place. Okay, so all places on a given meridian of a longitude have the same local time. Okay, have the same local time. So in the prime meridian of Greenwich has the sun at the highest point in the sky, all places along this meridian will have the midday or noon. So what does it mean? Now, if you take any of the meridian here, so I'll take any meridian over here. So what I will do? If you take any of the meridian over here, so let us assume here we have a place called as Delhi. So let us assume all of them are present on the same meridian, and here we have Bangalore. Okay, here we have Bangalore. If they are located on the same meridian, then whatever the local time we have in Delhi, the same local time will be also present in what? Bangalore. Okay, if they are located along the same meridian. But if two places are located on the same latitude, let us assume here we have what? One city. So I'll call it as what? Pune. Another one is some other city. So whether both of them they will be having the same local time? No, because latitudes do not have any relationship with time. Only longitudes have. Okay, longitudes have. So here in this example, Delhi and Bangalore, as they are located on the same meridian, they will have what? Same local time. Okay, same local time. Now, okay. So this is a global map. Okay, this is a global map. So we know that Earth rotates from west to east. In this direction it rotates. Okay, in this direction it rotates. So which region will see the sunrise first? The countries which are present in the eastern hemisphere or the countries which are present in the western hemisphere? So obviously the countries which are present in the eastern hemisphere will see the sunrise first. Okay, will see the sunrise first. That is why the local time of the places which are present in the eastern hemisphere will be ahead compared to the local times of the cities of the places which are present in the what? Western hemisphere. Why? Because Earth rotates from west to east. So those places to the east of Greenwich will be ahead of Greenwich time. So where do we have Greenwich? So Greenwich, this is the meridian. Okay, this is the meridian here. So all the places which are present over here, so the times, local times, so they will be ahead than Greenwich time. Okay, they will be ahead than Greenwich time. So what does it mean? So suppose that Greenwich, the time is now 12 o'clock. Okay, noon. So here it may be 1 p.m. or it may be 2 p.m. or 3 p.m. and so on. So they will be ahead. Whereas places which are present towards the west, so their time will be lagging. So if it is noon here, then probably it may be 11 a.m. here. So it may be 10 a.m. here and so on and so on. Okay. So those to the west will be behind it. To the east, they'll be ahead in local time, and to the west, they'll be behind. Okay, behind. So how to calculate the rate of difference? How much ahead and how much behind they are? So there is a formula. Again, from exam point of view, this formula is not important. Okay, this formula is not important. So at least to get an idea. So Earth rotates 360 degrees in 24 hours. So we already know. So for one rotation, Earth requires 24 hours. Okay, 24 hours. So one rotation means completely 360 degrees. We already know, right? So this is 0 degree. Next 60 degree, 90 degree, 180 degree, 270 degree. So total one round is 360 degree. Okay, 360 degree. So it means it rotates 15 degree an hour. In 24 hours, if it is 360 degree, then in 1 hour, it will rotate 15 degree. It will rotate 15 degree. So for 1 degree rotation, it will take place in 4 minutes. It means in every 4 minutes, Earth will rotate by 1 degree. Earth will rotate by 1 degree. So based upon this, what we can do is, here it is. So the time when it is 12 noon at Greenwich. So let us assume at Greenwich time is 12 noon. Okay, 12 noon. So 15 degree east of Greenwich and 15 degree west of Greenwich. So here 15 degree east of Greenwich, somewhere here 15 degree east of Greenwich, and somewhere here 15 degree west of Greenwich. So what will be the time here? So 15 degree east of Greenwich, it will be 1 hour ahead of Greenwich time, and 15 degree west of Greenwich, it will be 1 hour behind Greenwich time. So here it is 12 noon. At Greenwich it is 12 noon. So 15 degree to the east, the time will be 1 p.m. and 15 degree to the east, time will be 11 a.m. Okay, 11 a.m. So what we understood, through Greenwich time towards the east, time it is ahead, and towards the west it is lagging. Time is lagging. Okay, we are speaking about what? Local time. Okay, local time. So this Greenwich time, what it gives? It gives a what? Global standard time. Okay, global standard time. If at all we want to have a standard time across the globe, then which line we'll be using as a reference? We'll be using Greenwich line. Okay, Greenwich meridian as a standard reference. Okay. Next, very important point to note here. Similarly, at 180 degree, it will be midnight when it is 12 noon at Greenwich. So what we saw? From Greenwich, as we start moving towards the eastwards, so it will be ahead. Okay, it will be ahead. Similarly, when we reach 180 degree towards east, when we reach 180 degree towards east, 180 degree towards east compared to this Greenwich, so it means in Greenwich, if it is 12 o'clock, 12 noon, then here it will be midnight 12. Okay, midnight 12. So important point. Next, why do we have standard time? So a very important question. Okay, a very important question. Now, if you look at India here, so whether India has a standard time? Yes, India has a standard time. But whether the local time across India it is same? No, it is different. Why? Because we have different meridians. We have different meridians. In India, for instance, there will be a difference of 1 hour 45 minutes in the local times of Dwarka and Dibrugarh, Assam. So here in Assam and Dibrugarh in Gujarat. So if you look at the local time, so then there will be a difference of close to 1 hour 45 minutes. So what does it mean? Means if the sun in Dibrugarh, if it shines exactly overhead at 1 a.m. at 1 p.m. then at Dwarka, Gujarat, at what time it will shine exactly overhead? It will shine exactly overhead at 2:45. Because there is a time difference of 1 hour 45 minutes between Assam's Dibrugarh and Gujarat's Dwarka. Okay, so there is a time lag of 1 hour 45 minutes. So sunrise will happen here first, and after 1 hour 45 minutes, sunrise will take place at what? Dwarka, Gujarat. Okay, Dwarka, Gujarat. So if this is the case, then we will face some problems if we do not have a standard time. What is that? Now we want to schedule, we want to create train timetable and all. So when the train moves from what? Dibrugarh to Dwarka in Gujarat, it has to pass various longitudes. So if the local time used by this Dibrugarh if a local time is used, then what happens? The timings between this Assam and Gujarat, it will be confusing. That's why, in order to avoid this confusion, so across India we have adopted a standard time. Okay, we have adopted a standard time, and this standard time varies from what? Local time. So what is that standard time? How we have fixed it? So we have taken a meridian which passes more or near from the center through the center of India. Okay, so we have taken 82.5 degree as a standard meridian of India. Okay, so this standard meridian, so this will be considered as standard time. So sun exactly when it shines overhead on this line, so that time will be considering as 12 noon. And the same will be adopted by what? Eastern part of India, western part of India, northern part, as well as southern part. Okay, so here the important point to note here is, in India, which is the standard meridian? Longitude of 82.5 degree east. 82.5 degree east. So why we require a standard time? As we saw, in order to prepare timetable for trains and all which cross multiple longitudes, we need to have a what? Standard time. So in order to avoid confusion, so that's why we have adopted the meridian which passes through 82.5 degree east as standard meridian. And based upon this, the timings which we have fixed, we call it as Indian Standard Time. Indian Standard Time. Okay, so Indian Standard Time is fixed based on the meridian that is present at 82.5 degree east. So similarly, if you want to know the difference between the time which is present in India and England, okay, so India's standard time may not be the standard time of England. Okay, so in England the standard time is calculated with the help of the Greenwich. So already we have seen the Greenwich, right, because it passes through UK. So here the difference between the Greenwich and India's standard meridian is 82 degree 30 minutes east. So the time lag is 5 hours 30 minutes. So Indian time is 5 hours 30 minutes ahead of global mean time. So what is global mean time? So the meridian which passes through Greenwich, so based upon that, whatever the times we'll fix, so that is called as global mean time. So India's standard time or India's local time, across the India's local time, we call it as India's standard time. So that is ahead than global mean time by 5 hour 30 minutes. So even this information is important from exam point of view. So out of curiosity, we need to know about it. Okay. Next, across the globe, whether all the countries have only one single standard time or the standard time they may adopt multiple standard times. So there are examples wherein countries have multiple standard times rather than one. So when it comes to India, we have only one standard time. But when it comes to an example that we have taken here, Russia. So Russia has as many as 11 standard times. Not one, but 11 standard times. So why? If you look at the geographical extension of what? Russia. So longitudes extend from here to here. So it will be very difficult for them to maintain one single standard time. So that's why they follow 11 standard times. And how do they try to achieve what? Synchrony between that? So visually it is beyond our scope of discussion. But here we got to know that Russia has close to 11 standard times. Okay, 11 different standard times. Next, Earth has been divided into 24 time zones. Okay, of 1 hour each. So Earth has been divided into 24 time zones. So here we'll, if you look at this image, you'll get to know that there are 24 time zones, and each zone covers 15 degree of longitude. Okay, if you look here, each time zone, it consists of what? 15 degree of longitude. Okay, 15 degree of longitude. So this was about the topic, that is globe, latitude and longitude. So with the help of, once we understand this topic, then we'll exactly understand, or at least approximately we'll understand how the GPS system and all works, how our navigation application work. So this was about the globe. Similarly, in the subsequent classes, we'll be discussing about the other important topics related to UPSC. For all our updates, subscribe to our channel and hit on the bell icon. Thank you.